Ben Pearson, the Roaster Tracker. We're continuing our series of solar system exploration, talking with the innermost planet, which is the planet Mercury. Planet Mercury is a really interesting planet, and it's had a lot of history, and it's not really very well explored, but we're going to talk about what we know about the planet and its kind of history. So, anciently, Mercury was actually thought to be two planets, one that was around in the morning and one that was around in the evening. We've known for at least 2,300 years that it has actually been one single planet, but that was a common perception by the early Greek era. And kind of interesting about that, it is a very difficult planet to observe. I've definitely seen it a few times, but you have to kind of pay special attention to see it in the evening. Mercury is much more challenging than, say, Venus, which you can just pretty much look at in the morning and the evening, and as long as it's not really close to the sun, you'll see it very, very easily. Mercury, there's a lot of the time that it's just not there, and it's a lot dimmer than Venus. So the history of what we have thought about it from the telescope age is kind of interesting. Galileo was eventually able to observe some of the same phases that Venus has, which allowed us to know that, hey, it's closer to the sun than we are, even though it seems kind of obvious because it's always close to the sun physically. But that was considered a major breakthrough. When they started to actually be able to resolve some of the surface features, they thought that it was tidally locked. Now, for those not familiar, tidally locked is like our moon is always facing Earth more or less in the same direction. That's why you look up at it and it looks more or less the same. The moon actually can vary just a little bit from time to time, but that's kind of beside the point. You can never see the far side of the moon, though, from Earth. And for the longest time, this was thought to be the case. It was only in 1965 when we started to get radar observations that they predicted a different time, the rotation period of 68 days, where the period that it takes to orbit the sun, a revolution period, is like 95 days, or don't quote me on that. Look it up. There'll be a link in the description below with the link to Wikipedia that you can find all these facts if you want. In any case, that seemed very, very curious, and it was hard to understand why did we think it was tidally locked, because we were seeing these features at the same time and place every time that we observed it, but it wasn't tidally locked according to the radar. It's a huge, huge mystery. Eventually the theory came that, hey, maybe instead of tidal resonance, it has a 3-to-2 resonance, which means that for every 3 times that it will rotate, every 3 Mercury days essentially, it will revolve around the sun twice. So 3 Mercury days equals 2 Mercury years, which is unique as far as I know among any object that has ever been observed. And in fact, when we first sent a spacecraft there, that was one of the big missions, was to test if this 3-to-2 resonance theory actually held up. And Mariner 10 was able to successfully do that. Mariner 10 was a really interesting spacecraft. It was the first one to ever use a gravity assist. It flew by planet Venus on its way to Mercury, because getting to Mercury is very, very challenging. To orbit Mercury is more difficult, I believe, than it is to orbit any of the outer planets other than Pluto. And, it requires a lot of work, but doing these planetary flybys makes that much, much easier. There's only been a couple of other missions that have led to the planet Mercury. One was Messenger, which was the first one to orbit the planet. It mapped the entire planet in high resolution. Mariner 10, even though it did 3 flybys, because of this resonance, it was always essentially on the same half of Mercury. So there was half of Mercury that we had never observed anything other than through telescopes. And so we were able to get that in much higher resolution and actually see the entire planet, which is pretty cool. There is another mission that is on its way that is a combined ESA-JAXA mission. It's called Bepi-Colombo. They were going to send a lander with it, but it's just too darn difficult to actually land on the planet. If you've ever played the game Kerbal Space Program and you ever have tried to send a mission to Moho, you'll know how challenging it is, and Moho is essentially Mercury, right? So I have yet to successfully land a mission on there. One of these days I'll get there. When Bepi-Colombo successfully arrives there, there's going to be a couple of orbiters that will deploy that will help it to be able to better understand the planet. It'll be pretty cool. There have been a couple of other proposed missions. My favorite one, which I think I did a video on, and I'll try to link it maybe here, that there was a brief period of time where they were considering taking Cassini and instead of crashing it into Saturn, as they did, to have it escape, do a flyby of Jupiter, and end up crashing into the planet Mercury. I don't think that was ever really that seriously proposed, but it did make a news article, which I found amusing. As previously mentioned, Mercury is by far the least studied planet of the inner solar system because it's so hard to get to. Some of the more interesting things with Mercury is it's very dense. It's almost as dense as the Earth, but it has absolutely no atmosphere whatsoever, which again makes it more challenging to visit. You have a lot of heat to deal with because you're closer to the sun. You have to have a spacecraft that can deal with that thing. In theory, if you could somehow survive in a spacesuit, you could walk around the planet and stay in a semi-habitable region that was the Terminator. So the Terminator is the line between day and night, and that's a reasonably nice temperature region. A lot of science fiction, more modern types of things, will talk about a moving city that will always keep in this kind of twilight to keep the temperatures reasonable. Because if you go on the cold side, then it's really cold, and you also don't have any solar power. If you go on the hot side, it can get to be super, super hot. So you want to stay nice and center. But theoretically, you could have a person that could walk along this Terminator because it moves so slowly. It's well within human walking speeds. And there's some kind of science fiction that speculates, that could be like a journey, like a spiritual type journey that some people do for some period of time. Mercury could be a useful planet for mining, particularly if we wanted to, say, build a set of satellites that was close to the sun to capture a lot of solar power and broadcast that power to elsewhere in the solar system. Otherwise, it's not really the most interesting. It probably doesn't have life. It has very, very extreme temperatures. It probably has the most extreme temperatures of any planetary object in the solar system now that I think about it. It's probably true. Because on the day side it can get very, very hot, and on the night side it can get very, very cold, unlike the planet Venus. It's a neat little planet. I certainly would like to see more missions there, but considering how difficult it is and how many other interesting targets there are in our solar system, I can forgive there being fewer missions there. I'd far rather see one of the outer planets like Uranus or Neptune get a mission than Mercury. I think that would be pretty neat. Thank you guys so much for everything. Let me know whatever questions or comments you guys have. Until next time, keep on tracking. Take care, guys.